Alright, you're welcome again. Today, let's take this question under integration. Alright, we have find the integral of dx all over square root of x plus x. You get it? Find the integral of dx all over square root of x plus x. Now, let's go. How can we solve this problem? Now, let's take a look at the denominator. We can do something about that, right? Okay, let's try and factor out square root of x. If you are to factor out square root of x in square root of x, you are going to have 1 remaining. That is, when you say square root of x times 1 is going to give you square root of x. And then when you factor out square root of x in x, it's going to give you square root of x. Because when you say square root of x times square root of x, it's going to give you x. Is that true? Yes. So that means now we are having the integral of dx all over square root of x, open bracket 1 plus square root of x. Because when you use the square root of x outside to open the bracket, it's going to give you the same values above. Okay? Yes. Now let's go. I can rewrite this in this form. The integral of 1 all over 1 plus square root of x, close the bracket, times dx all over square root of x. You get it? It's still the same thing because when you multiply this, it's going to give you the same thing as what we have. Now from here, we make use of a simple substitution. We're going to say let t equal to 1 plus square root of x. So we're going to replace 1 plus square root of x with a letter t. You get it? Now, let's go. This function t that we are having now, we are going to differentiate it. We are going to differentiate this function t with respect to x. But let me show you. This t we have 1 plus square root of x. Now this square root of x can be written as x raised to power 1 all over 2. Is that true? Yes. Now let's differentiate properly now. We're going to have the t all over the x is equal to, we bring this 1 all over 2 down, right? We're going to have 1 all over 2 x raised to power minus 1 all over 2. That is when we differentiate, okay? We're going to have the t all over the x is equal to 1 all over 2 x raised to power minus 1 all over 2. You get it, right? Good. Now, let's go. We have the t all over the x is equal to, this x raised to power minus 1 all over 2 can be written as 1 all over x raised to power 1 all over 2. So that means we have the t all over the x is equal to 1 all over 2 times 1 all over x raised to power all over 2. Okay, now let's go. So we have the t all over the x is equal to 1 all over 2. This x raised to power 1 all over 2 can be written as square root of x. You get it? So we have 2 square root of x. All right? Yes, here we are having the t all over the x is equal to 1 all over 2 square root of x. We can cross multiply, okay? So when cross multiply, we're going to have 2 square root of x dt is equal to dx. Now, if we go back to our function, we have the integral of 1 all over 1 plus square root of x times dx all over square root of x. So we want to substitute, we want to get a value that we can replace this dx all over square root of x with. Hello. So in this function here, this one we differentiated, we are going to try to figure out the x all over square root of x. So here we are having 2 root x dt equal to dx, and then we want to get dx all over square root of x. How can we obtain it here? So we can simply divide both sides by square root of x. So that means we are going to have 2 root x dt divided by root x is equal to dx divided by root x. Get it right? So here root x we cancel root x. We're going to have 2 dt is equal to dx all over square root of x. You get it right? Yes, that means in this place that we say let t equal to 1 plus square root of x. As we replace this function with t, we are also going to replace the x all over square root of x with another value. Which value? 2 the t. Do you get it right? Yes. Now let's go. Let's substitute properly now. We're going to have integral of 1 all over. In place of 1 plus square root of x, we'll replace it with t. And then in place of the x all over square root of x, we'll replace it with 2 the t. Everything rhymes. You get it right? Yes. We can take the constant outside the integral sign. If you do so, we're going to have 2 integral of 1 all over t dt. Now let's integrate properly now. We're going to have 2. The integral of 1 all over t is going to give us nt. Then we have plus c. Then you remember that we said that t is 1 plus square root of x. We can replace it back. So we're going to have 2 ln 1 plus square root of x plus c. Alright? Yes. Thank you very much. Let's take more examples for easy and better understanding. Alright? Yes.